Welcome, everybody. Welcome to the first DevOps Belfast of 2023. I'm delighted to have Ali from Infracost with us today. He's going to talk to us about cloud costs, cloud cost modeling, and what we can do to manage them. We can take questions during the talk if that suits you. There's a chat box there. You can drop them in there, or you can raise your hand and I'll try and unmute you. But yeah, if you've got questions, please ask them throughout. We'll have a Q&A section at the end as well, if you want to hold your questions to the end too. Other than that, I want to say welcome, Ali. Thank you very much. And over to you.
Thank you very much, Simon. Let me share my screen. Let me know when you can see my screen. All right, that's good enough. Okay, let me just click on this. Let's see if this works. Hi, everyone. My name is Ali, and I have a problem. So around 10 years ago, I started looking at cloud costs as part of my PhD research. And back then, there was about 10,000 price points. And I was just scraping them manually for my research. Today, there are more than 3 million prices between AWS, Azure, and Google. So it's been 10 years, and I'm still building tools for cloud costs. And I have this unhealthy obsession in this space. And this whole space is just too damn complicated. So back in 2012, I built one of the early cloud cost management products. It was called RightScale Cloud Analytics. And that was before EC2 had Cost Explorer. And our product was really helping managers and finance teams buy RIs, shut down unused instances, and so on. And after 4 years of building that product, I started another startup, and that time I was developing a public container as a service platform. So we were essentially running Kubernetes on bare metals at large scale. And that was also fun because we built our own billing engine for Kubernetes in 2016, and we were charging for things like 100 megabyte RAM minutes and storage hours. And that startup was also acquired. Now, here's what's been bothering me for the last 2 years. So this is what the current checkout experience looks like for engineers buying cloud resources with Terraform. And it's the same with CloudFormation, Pulumi, and the other infrastructure as code tools. So it says this change is going to add 18 resources, change 4 resources, and destroy 2. Do you want to perform these actions? And I'm like, yeah, okay, whatever. So I apply those changes, months and months go by, and the cloud costs just keep rising until that budget's blown. And that's when this pain train starts. And we've seen it over and over again at companies. And it often starts from the CFO, who shouts at the VP of engineering, who then shouts at engineering management, who then shout at DevOps, SRE, or the dev teams. And I'm like, what did we expect? The engineers didn't see any costs in this provisioning cycle, and no one really understood the cost implications until it was too late.
We can see your whole desktop now.
Now we have to go back and change things. And that's bad for 2 reasons. One, that money has already been spent. It's not coming back. And 2, we now need to burn more time to go fix any of those issues. So I think people should know how much stuff costs before they buy it, regardless of whether I'm buying a shirt or an EC2 instance. I should know the costs. So in this example here, did you know that if you have provisioning IOPS enabled, that will add $52 a month to your costs? And multiply that by thousands of engineers at these large enterprises with those millions of prices, it adds up. And it's like death by 1,000 cuts. So we think if you know those costs and the levers that can be used to adjust those costs, you're more likely to make better decisions. And that's one of the aims we're trying to solve with Infracost, is to help you make better decisions before you buy those resources in your workflow. Now, the first question is probably going to pop up, like, how can you do this for S3 or Lambda or any of these usage-based resources, right? How can you even know the costs? Because, yeah, you can do it for EC2 or fixed resources, but what about all those other things? Well, we can still explain which of those 2 or 3 price points out of all of those millions of prices apply to you in this resource. So for Lambda, we can say you're looking at request and durations, and the cost depends on the usage. So we can still explain that to the engineers very easily in the workflow. And then they can define usage in a YAML file. So they can say, hey, what if that Lambda function gets 1 million invocations a month? And what if the average duration that I looked this up on like Datadog or Grafana or wherever, it's 150 milliseconds. If I have those 2 parameters, I can then give you a quick cost estimate. And what we're working on right now is to fetch the actual costs from the billing CSVs and bring that into the workflow as well. So we can tell you that this Lambda function over the last 30 days had this number of invocations and it had like this number of request durations. So we can kind of bring all that context into the workflow too. So I'm going to talk about some use cases that we've heard from the community of users, and then I'll talk about some of the challenges and why doing this stuff is kind of hard behind the scenes as well. And I'll talk about Infracost. So Infracost is open source. All this stuff I'm going to show you, you can do yourself. And we're backed by Y Combinator and Sequoia Capital. And then there's an Infracost Cloud product, which is a SaaS product that builds on top of the open source stuff. And that's our paid product. So the way we're thinking about it is the use cases that engineers are trying to solve, which are often around cost visibility. And it's often we're seeing for self-service infrastructure at large companies. So a central team who owns the platform, the infrastructure, the Kubernetes clusters, they're setting up kind of the Infracost for all the other dev teams to see in the workflow. That's what we see a lot of. And those use cases are kind of part of the free open source part, because we're very much following a business model similar to GitLab, which is called open core. So the use cases that individual contributors are trying to solve, we want to keep them open source and free. The use cases covered by management, we're kind of trying to monetize those. So the second use case we see is often from managers and FinOps teams, and really their focus is on saving money and time. And then we see one area kind of less, but we still see it, is consultants who are often going in as contractors into larger companies, and they're helping their clients adopt and scale in the cloud, and they're putting in Infracost for them as a kind of a best practice, and they walk away. And all of this is there to kind of make you love your cloud bill. Now, it's a very hard thing to love a bill, but by love your cloud bill, how can you love something that surprises you, shocks you, has negative feelings? Those are the things we're trying to remove from this space. Those are the emotions we want to get rid of. Because if you understand it, if it's predictable, if there's no shocks, there's no stop the train, we need to cut costs by 20% this quarter, don't do any dev work, we're just going to do this. If we can get rid of those feelings, that's us way closer to being able to love our cloud bills. So 30 years ago, engineers had an eye on memory usage, but these days you just pay more and you just buy more memory. So when building systems in the cloud, you now need to start having an eye on costs. And I don't think this is from like an engineering perspective. I don't think this is just about saving money. I think it's just good engineering to build efficient systems. And cost is just a new dimension in the systems we're building these days. So what we see a lot of is DevOps, SRE, and infrastructure teams are enabling the other dev teams to provision infrastructure as and when needed. And it often follows a self-service model where they're using things like Terraform modules or Pulumi libraries, and they're building the kind of building blocks, but they're not the ones provisioning those things at scale in the company. It's all those tens, hundreds of engineering teams that are doing that and configuring those models. And that central team often owns the provisioning workflow, whether that's being done with Jenkins, Atlantis, or any of the other kind of CI/CD tools. And what we see a lot is people take Infracost, the CLI tool, and they put it in the workflow so the engineering teams can see cost estimates before those resources are launched and changed. And the aim is to develop a cost-aware engineering culture. So that central team is doing that as a best practice for all the other dev teams. And what we see a lot of is Infracost is sitting next to things like Chekhov, TFSec, and TFLint, or any of these other tools that are kind of sitting in the CI/CD pipeline. And if you look at kind of a bigger picture, the security space is, I think, more mature. The security tooling is way more mature than the cost tooling. So you have a lot of tools these days that can scan your code, and you don't really need to worry about things like SQL injection, because there's tools that are kind of scanning and telling you, hey, you're about to make a big mistake. And we're trying to do the same thing with costs by automating this. So how does it work? Well, it starts in the editor, because that's as left as we can shift this whole thing to. So when you're writing Terraform, in the editor, you can install this VS Code extension, and you can see, okay, I've just written an instance block, and if I just change the instance type, this cost updates. And if I copy paste this below it, I can change the IOPS and storage, and I get 2 cost estimates. So right in the editor, I can just tweak things, copy, paste, and I get kind of that immediate feedback loop. Because Infracost is a CLI tool, you can use it in the terminal. And in the same way that you just run git diff, you can run Infracost diff. So it does a diff, but on the costs. So when I change some code, it tells you, hey, you're about to change this instance type to this, and that's the old cost, that's the new cost, there's a diff. So you can kind of see a diff in the editor. Why is that good? Because it enables things like pre-commit Terraform, this awesome project from Anton Babenko and the rest of the community, to build tooling around costs as well. So I can have commit hooks that say, hey, before this code gets checked in, just run a sanity check. Like, I didn't accidentally provision something that's going to cost like $10,000, because that's not what I intended to do. So because it's a CLI tool, you can also put it in pull requests. And this is the kind of main team workflow we see. Pull request is where we come to discuss things like security issues, performance issues, code quality, and Infracost enables you to do the same with costs. So you can discuss costs in the workflow, whether you're using GitHub, GitLab, Bitbucket, Azure repos, wherever the code lives, we want to put the pull request comment right in there. So we start to kind of build up that cost muscle across the teams and have that engineering culture where we're not just ignoring cost as if it's somebody else's problem, because we're the ones that kind of write the code, and we're the ones that are kind of making a lot of decisions every day about what do we buy. So how does it work in terms of vendor support? It supports AWS, Azure, and Google, because there's a community of people writing in the same way that Terraform has providers. And there's a community that own the providers and make sure they're up to date as well as HashiCorp themselves. We're kind of running the same model here, where there's a community of people adding resource mappings for AWS, Azure, and Google. And there's requests from the community to add other things like Mongo costs and anything else that you're kind of provisioning with infrastructure as code. It supports Terraform right now, and the Terraform CDK as well. There's a pull request being worked on by the community on Pulumi. We've got plans for CloudFormation and ARM as well. So we kind of want to go broad, where it doesn't matter what infrastructure as code tool you're using, you can still run Infracost, and it just tells you, because all code has costs. It's just up till now, it's been very invisible, and we're trying to make that visible. Infracost has JSON output, which means you can integrate it with things like OPA. If you're using, if you're writing policies in OPA or Sentinel, you can do that. And that's useful because you can then create guardrails and kind of centralize cost policies to automate things across the teams as well. So with OPA, we've got native integration. So you can, when the pull request is coming in, you can write an OPA rego policy and say, hey, if this condition is not met, add this comment into the workflow. So summary so far, we're putting costs for everything everywhere, and that infrastructure shopping cart I showed at the start of the talk now has costs. Questions so far? Maybe I'll pause for a minute.
Yeah, perfect timing. We've got one question queued up in chat. Michelle wants to know how much does Infracost cost? So I think you've already touched on the fact that the tools are open source, but there's a service too.
Yeah, exactly. So the CLI tool and the cloud pricing API, which has those 3 million price points, both of those are free open source. And the Infracost Cloud product, which I've got one screenshot that I'll show, that has a per seat pricing model where you basically pay for anyone making infrastructure changes needs a license. So if you think like an engineering team of 100 people, often we see like less than 10 people, or around about 10 people are the ones who are like owning the infrastructure pieces. So you need 10 licenses. It's the same kind of model that other security scanning tools are following. And the current price on the pricing page is $50 per seat per month. And you can kind of buy that monthly. But again, what we see is a lot of people start with the open source, and when the management want kind of visibility across teams and repositories, and they want to kind of put in guardrails, that's when those use cases start being in the paid tier. Any other questions? And then I'll just touch upon the cost of Infracost in terms of how much resources it needs to run, because this thing is running on every commit in CI/CD systems, which is a lot of runs. So because it's parsing the HCL code directly, it's super fast. We're trying to get it for even large repositories to be less than a minute. But as some of our enterprise users are finding out, for mono repos, which have like hundreds of projects, currently it can take anywhere between like a few minutes to, I don't know, 10 minutes. But we're working on that just now, where we only run Infracost on things that change. So we don't run it across the whole repo. And we're aiming it to make it like less than a minute, basically. So you can keep running it in CI/CD on every commit. That's the aim. All right. Second use case. This is mainly coming in from engineering management and FinOps teams. And in 2022, public infrastructure spend was roughly estimated to be about $120 billion. And the industry estimates show about 30% of that is waste. So engineering management are often the ones that need to manage this cloud spend across all those engineering teams, across the company, essentially. And brand new FinOps teams are being formed too. So there is a FinOps foundation. People are being certified, because this isn't a space that is controlled or kind of understood well just by engineering. It needs a lot of finance people to kind of come into it, because when you're making purchase decisions about RIs, or whether you want to, spend a lot of money up front to get lower costs down a year down the line, you kind of want to manage the cash flow. And so it's this space between engineering and finance, and hence why there's brand new FinOps teams being formed, which are often a mixture of people who are coming in from finance and kind of engineering to see, okay, what do we do? How do we manage this cloud spend and the waste in between there? So why is there so much waste? The status quo, I think, is the closer you are to the code, the further you are from the costs. So if you look at in engineering roles like DevOps or infrastructure engineers who are provisioning a lot of heavy infrastructure, or the dev teams themselves, they're the ones who are buying the resources daily. But engineering management is often the ones who are getting the bills and having to pay for those resources. Now, the timeline of people making code changes is like tens of pull requests every week, or hundreds of pull requests being made every week. The timeline at the top is a bill at the end of the month, or quarterly reviews of costs. So they're working on very different kind of timelines. And this feedback loop is just not tight. And that's why we think there's a lot of waste, because the people who are buying and making a lot of decisions don't understand the cost implications. And by the time the issue becomes big enough that they need to do something about it, those people have moved on to other project areas or product areas, and it's painful to go back and change things, because the product backlog is always filled in with new capabilities and new things they want to do. And it's hard to kind of get engineering teams to essentially take action and go back and say, hey, that thing you did 3 months ago, can we go back and change that? So that's why we think there's a lot of waste, is because this feedback loop is just not tight. So what are we doing about that? Well, that's the space Infracost is looking at, Infracost Cloud is looking at. And this is a SaaS product that builds on top of the open source. And it really gives team leads and FinOps a tight feedback loop. So you can create centralized guardrails, policies, and reports to review those changes before they hit the bill and really help guide the team. We're not trying to create workflows where the engineering teams are blocked. That's not what we're trying to do. Instead, we're trying to bring context into that workflow so those engineers are making better decisions. Or when FinOps teams find out, hey, you're about to provision 100 instances for this new thing, it would be nice if you give us a heads up. Why? Because we're the ones that buy RIs and manage the purchasing decisions kind of decoupled from that. So if you give us a heads up from the workflow automatically, we're not surprised 2 months down the line. One other use case we see is when there's a cost spike in the actual bill, it often can come from two sources, right? Either we changed something or there was a spike in user traffic. And when you look at Infracost Cloud, you can quickly see what was happening in terms of pull requests or changes to the infrastructure at the time we had a spike. And you can quickly find the right people to talk to. Because again, if you're in the FinOps team or in the engineering management team who are owning the cloud bill at these large enterprises with thousands of people, often there's a small centralized team for hundreds of engineers. And it's hard to find the right people to talk to because, well, there's a ratio of 1 to 100 between them. So that's the space we're working on Infracost Cloud. What does it look like? It looks like this. So here's a dashboard. This chart is essentially showing you pull request changes over time. So each dot is a pull request. Changes above this line are pull requests that increase the bill. Changes below the line are pull requests that decrease the bill. This below the line is really important for me because I think often it gets lost in the noise. So when you look at the actual bill, it goes up usually month over month. Or if you're lucky and you're working on a cost reduction exercise, it could go down. Now, within that bill, there was a lot of effort that engineering teams did to control the cost and reduce it, but often that gets lost in the big bill picture. So if we sum up all the dots underneath the line, we can see actually we made a bunch of changes that saved the company this much money, and that isn't necessarily reflected in the net costs. So if you look at like the net cost of bill over time, you don't see those small changes, and those are the things we kind of sum up and show to engineering management as well, because it creates that positive kind of feedback loop where you can thank the teams who are making a lot of good changes too as well. We recognize that the bill is going up, but if we didn't make all those efficiencies, if we didn't make all those changes, it would have been even more expensive. You can do things like set up guardrails. So you can say on the production projects within all repos, if a pull request increases the cost by more than 20%, customize the comment and notify the FinOps team. So you can kind of set up this kind of notification system. You can customize the pull requests and set up essentially alerts. So those are all the changes. Looking at Infracost Cloud, you kind of get visibility across all the repositories. I showed the custom guardrails. We're working on things like policies as well. So you can try and automate things like, hey, we're moving everybody from GP2 to GP3. Can you automatically scan all the repositories and show me which ones are the ones that need to be changed so I can create an issue in Jira boards and get those teams to kind of action it when they have time. A lot of large companies who are often spending like more than $1 million a year on cloud often get custom discounts and custom price books. So those are things we can kind of configure in Infracost Cloud 2 to say, I get like a 10% discount on my Azure costs. So you can customize that, and the pull request effect takes that into account. And there's a lot of other integrations with tools like Jira, because when you go outside of the engineering team, the workflow isn't necessarily all about GitHub. It's about product management, project managers, FinOps teams, team leads. They're looking at things like Jira. So we're pushing cost estimates and the cost associated with changes into those Jira tickets too. You can set up custom reports. There's team management, SSO, the usual kind of enterprise features to make teams succeed at scale. Those are all kind of part of Infracost Cloud. So ultimately, we think it leads to a cost-aware culture, and the thesis behind the company and the project Infracost is the Prius Effect, where a large subset of Toyota Prius drivers were shown to respond to the data shown on the dashboard by driving in a manner that decreased fuel consumption. So we're wondering, if we make engineers aware of the costs up front, if we make it super easy for them in the workflow, so there's not a lot of friction, it all works in like it looks kind of like magic when you start using it. Does that get them to make better decisions? That's what we're trying to test here. Again, I'll pause to see if there's any questions.
There's one question. I think you've covered most of it already about Infracost raising awareness of changes that you're making and the impact to your monthly costs there. The question goes on to talk about what happens when your cloud costs change. So I think what they're trying to get at is, say AWS reduced the price of a certain service. Where and how does that show up? So you had a scatter graph there of PRs and their positive and negative impact on your recurring costs?
Yeah, that's a good point. So the cloud pricing API self-updates the prices. So when AWS, Azure, and Google change the prices, the latest prices are pulled in. So when you're looking at the pull request comment or the main branch of a repository, you're always seeing the latest prices. There is a history in Infracost Cloud of the main branch run over time. So when the prices change, you could potentially look at the main branch costs, but there's a lot more we could do. And usually, like in between 2012 and 2016 or so, usually the prices just went down. There was a lot of competition between the three providers, and the prices usually went down. And we would write blogs that looked at the impact of that. What we might see is prices going up a little bit due to inflation and other kind of pressures on these companies. So there are certain things we can do in Infracost to basically say, hey, if the prices change, what is the impact to me and my repositories? But at the moment, we just show the latest prices in the pull request comment. But that's a really cool idea.
Cool, thank you.
Any other questions? Cool. All right, so this final part of the talk, I'm going to look at all the challenges, and specifically, I'm going to show you some code as well to kind of illustrate why this thing is hard, why costs are really complicated to kind of try and solve automatically. So how does Infracost work? Well, I mentioned it's open source. There's a CLI tool, and that CLI tool parses the Terraform HCL code, or it parses the plan JSON file. So what it's looking for is essentially all the cost-related parameters. And that CLI retrieves the prices from the Cloud Pricing API. And I mentioned there's a hosted version of that you can use for free, or you can use the self-hosted version. What we see a lot is companies in banking and insurance who have very tight requirements around environments and being locked down. They use the self-hosted version. Everybody else uses like the hosted version because it just has the prices. And the CLI is pulling in the prices just for the cost-related parameters. So it says like, hey, an instance type on this region of this size with this much storage, how much would that, what's the price of that? And it does the calculations on the CLI side. And obviously no cloud credentials or secrets are sent to that API. The whole reason we have a CLI on the server side is to kind of split the parsing. So all of that happens client side on your machine. Then that CLI can post comments to your source control system. It can save text or JSON output, so you can use it for other integrations. And the step 4 is where we see a lot of teams do, is to basically put it into CI/CD so they can kind of set it up and it just works going forward for all the teams. Now, I'll talk about two of the main challenges we see. One is just parsing infrastructure code. So if you already have a plan JSON file, great, Infracost can parse that. But generating a Terraform plan can be slow, and it requires cloud credentials and secrets. which is not great. So if you're sitting in one of the infrastructure teams and you have access to cloud creds and secrets, you can still generate a plan. But if I go around this room and kind of say, hey, who can generate a plan for me right now, like on the repositories, I suspect that you're going to run into some errors, like you're going to need some inputs, you're going to look up some creds. So it's just a lot of pain. You can do it because infrastructure engineers have access to all those things, but it's just slow and painful. Now, if I go to an engineering team who are consuming the Terraform modules or the Terraform constructs that the infrastructure teams are setting up for them, and if I ask them to generate a plan, it's going to be even more painful. And some of them might not have access to all the cloud creds needed to create those plans. So for that reason, we parse the HCL code directly. And again, this is similar to a lot of security scanning tools they do. They just scan the code directly. Why is that hard? Well, it means we have to write a parser that understands the Terraform language constructs. It means it has to download Git modules, registry modules, public and private, and there's TerraGrunt. There's a lot of companies, especially larger companies, who use TerraGrunt, and that has a slight different variation on how the projects are set up. And then users need to be able to pass in var files and var variables, and those often can live in things like Terraform Cloud or M0 and these other systems. So the challenge for us is that there's no standard provisioning workflow. Everybody runs infrastructure as code or Terraform in a slightly different way with a different mix of tools, different versions, and that makes it quite fun and challenging for us to, to support. What we've seen over the last 2 years is the complexity of the projects are just going up and up and up. So those monorepos are getting larger, the complexity is just getting more, and that's where we're investing a lot of time on just now, is to be able to handle those enterprise repositories, because the smaller projects are easier to run. If you're running Infracost on a single module repo, that's often way easier to run. The cool thing is the community. So lots of people in the community are running Infracost on those repositories and creating GitHub issues. And when they give us those reproduction steps is when we can quickly fix it and kind of jump on to the next one. So what does it look like behind the scene? It looks like this. This is part of the open source code. So how do we estimate the cost of an EBS volume? Well, you start parsing the type first. And if it's GP2, you apply special pricing to it. If it's GP3 and it has throughputs of over 125, still different prices. So it's a lot of parsing text essentially behind the scenes. So that's one part. And the other part is then finding, okay, this parameter in the code, what price does that map to on the other side? Which of those 3 million prices does this parameter map to? Because the infrastructure code doesn't have that, right? The mapping. So how do we do that? Well, manual work, that's how we do it. We go to we and the community, some of the community members are on the call too. We go to the pricing web pages, we read the pricing web page, and we see, okay, so this pipeline integration activity timeline, which is that parameter right there, that probably maps to, I don't know, this parameter in this. And we basically are saying, okay, this parameter maps to this, or if these 3 parameters are set, this pricing applies. Now, once we've coded up that mapping once, the whole community gets it for free, right? So once this mapping for this resource has been done, now I can just cost estimate this resource going forward easily. And what's interesting is we basically are kind of automating a lot of this manual work. So we're writing mapping code between Terraform, between CloudFormation, and all these kind of other infrastructure infrastructure as code tools. We're writing mappings between those and the cloud pricing web pages. That's the kind of the glue in the middle that Infracost fills. The pricing API I mentioned has those 3 million prices from all these things. So that's the thing we use to query. Why do we not query the cloud providers directly? Because they don't have good APIs for pricing. It's that simple. AWS just gives you like 2 gigabytes or a gigabyte of pricing JSONs. So when you're trying to write code that you want to run on every commit in a CI/CD pipeline, you can't load 2 gigabytes of CS JSON and kind of find the price. That's just not going to work. So you need to do a lot more caching and be able to look up things fast. So that's the second technical challenge, is just doing this mapping work. Now, that mapping code for something like Azure Synapse would take like a day or 2 days. For S3 has 55 price components, and each price has like different price points depending on the inputs. There's different usage tiers, different regions, and this is what I mean that it's just too damn complicated. So S3 took, I think, Alistair like a week to write. So for a week, Alistair was like looking at the S3 pricing webpage and trying to really understand how does S3 actually work in terms of pricing. And that took him a week to write the logic between that and the Terraform code. So it's complicated enough that we've got unit tests for this stuff. So when S3 changes the prices or Terraform changes a parameter, the unit tests start failing to say, hey, something's changed in the pricing or the parameters, and we need to go update that mapping logic. And that's when we then release a new CLI version, which has the latest mappings. And the users often pick that up automatically. Believe it or not, there's also been cases where, as we're writing this logic, we find bugs in the pricing itself. So we then reach out to Azure and say, hey, your pricing API doesn't actually match what your pricing webpage says. So something's off there. You guys go fix it. And this is how the community is helping. So we've added mappings for like 250 resources across AWS, Google, and Azure. There's about 550 free resources we've identified as free. And there's a community of more than 50 contributors doing this work. So the users are often sending feedback, requesting new resources, reporting bugs on VS Code or the CI/CD integrations, because whilst we've got like a GitHub action set up, if you're a large enterprise running Infracost in some specific permutation with Terragrunt on an enterprise CI/CD system, like and it runs into an issue because of that integration, if you can report that back to us, that's how we can kind of fix it quickly. And then we work with the community to test those fixes and ship them. And then there's about more than 700 people on the Infracost community chat, on the Slack chat. So just a big thanks to all the contributors, really, who are helping with this project. So I'll stop here. If you're interested in trying it, there's a link to the docs. And if you'd like to contribute, there's a code. Thanks.
Yeah, if you have any, and girls, if you have any questions, anything you want to talk about now, unmute yourselves and we'll work it through. I have to admit, I'm an Infracost user for some projects, and it's been thrilling having the feedback on a PR to say, yeah, you're going to change this and it's going to cost, your cost is going to change by this much. It's gives you a level of visibility that, yeah, it just hasn't been available before, and you just kind of cross your fingers and hope you don't go bankrupt.
That's the feeling we're trying to change. That's the feeling we're trying to change.
Yeah.
I'll stop my screen share so I can also see the chats as well.
So so you mentioned there about talking to some of the cloud providers and say, your published price doesn't match what we're seeing in other places. Have you had any positive feedback with them, or any positive interactions with the cloud providers on how they can make pricing APIs better and more digestible for people?
Yeah, so yeah, we've had meetings with like the AWS pricing teams. This is also a problem that's hard for them. So often they have a centralized pricing team that provides the infrastructure for them to do pricing. And then each of their service teams has different pricing, and it's kind of like their responsibility to use those pricing frameworks to push those things in. So it's very much a distributed problem at scale at these large cloud vendors. And for them, I think the incentives are also a bit off. Often, if they make it super easy for companies to save money, it hurts their bottom line. So if you look at like one of the cloud providers built on APIs, but when did they add the pricing APIs? When did they add the costing APIs? That was always like way later in the game. So in a lot of ways, I don't think it's a huge focus for them. Like their focus is mainly on shipping services and features, and often this stuff feels like it's an afterthought sometimes. But because the cloud bills, like 10 years ago, the cloud bills were high, but it wasn't like $120 billion. Now, the entire companies are just running on the cloud. These numbers are gigantic, and the waste is gigantic. So it's a lot more important to kind of treat the cost and price parameters as kind of a first-class citizen versus like, yeah, we'll just optimize it like later. Well, there's 10,000 engineers at this company. Everyone's making changes. You're going to optimize like all of this stuff later. Okay.
You mentioned there about the AWS S3 resource having, do you say 55 different parameters?
Yeah, prices. Yep.
Prices, yeah. And is that something you've simplified in your model of what an S3 bucket costs you, or are they exposed in your costs.yaml where you get to say, we're making 1,000 requests a day against this?
Yeah.
And they're from this country and this country and this country.
So initially we exposed it all, and the users were like, so you've just given me a list of 55 prices that I don't understand what this means. So what we've learned is by default, just show them the most interesting stuff. So for us, I think for S3, we just show like the 5 prices, like storage, data transfer, read and write, or put and write requests. And then in the usage file, you can go in that YAML file, you can say, okay, but I'm using S3 intelligent tiering and I'm using it this way. And then if you do that, then you get the prices for it. So what we've often seen is engineers don't have like hours to spend on this stuff. They have minutes. So it needs to just be very simple to understand at a glance in the pull request, which means when we're writing the mapping code, we kind of have to make a bunch of decisions like, how do I make it so somebody who doesn't really use S3 day in, day out, I've got a minute to make them understand what's important. So that's where a lot of the mapping code also comes in, is to say, hey, just show them the main stuff. And then if they want to dig into it because that cost is high or they're doing some really big changes on S3, then they'll get into the details. But like if an engineer has to like look at every pull request like in a detailed manner, is too much work for them. So what we're often doing is like 90%, 80 to 90% of the pull requests should just be like tap on the back, well done, no big mistakes, keep shipping, keep shipping. Because the whole point is to keep them shipping fast. We don't want to slow them down. Yeah. Right, so those 10 to 20 pull requests are like, hey, are you sure you want to add this $20,000 instance type? Like, did you even know this thing was 20K?
Cool. I could talk all night. I'm going to carry on talking until people come up with other questions. I think that's my role in DevOps Belfast. People haven't thought of yet. You had a screenshot in your slide deck, and it was feedback on a particular PR, and it seemed to identify costs for different parts of the repo.
Right. So
how does Infracost deal with repos that contain multiple code bases, multiple that one there? So yeah, that's from my point of view, that's 2 different stacks inside that repo. This is multiple projects, I suppose. How do you identify those? Do you see changes to all stacks, some of the stacks? What?
Yeah, great question. So the default used to be that we would show the entire repo, and we identified each folder or each workspace as a different kind of stack in that line, in that summary line. Working with many monorepo users and large kind of companies, we've learned that that doesn't work. It just is too much and it doesn't scale. So the definition of a stack is also different between companies, what we see. So what we're working on right now, literally this week and next week, is for 2 main changes. One, you can describe the structure of your repository. So in a config file, you can say, hey, in my repository, a project is this glob pattern or this kind of level in the directory structure. So you don't have to spell out those individual projects. You just have to describe the structure. So we know which ones are what are the folders you want us to roll up the cost to. And the second change we're making is in the pull request, because we now understand the project or the stack structure, we only show you the ones that have changed. So think of it as like every, I don't know, couple of hours, the main branch, all of the projects are kind of run. But on each pull request, we only look at the ones that have changed. Or another way to put it is the main branch is essentially the sum of all the individual stacks in that project. So in the pull request, we only need to show you the ones that have changed. But if you want to see the whole cost in Infracost Cloud, we can sum up all those projects and show you the total. That's again another space where working with the communities has been really useful, because when you're writing tools and when you're developing tools, you need real world kind of project examples to dig into, and toy examples just don't cut it.
Yeah, I don't envy you having to deal with the different project structures that we all come up with for running Terraform and Terragon projects. That must be
and it's often what we often see. It's like you can see the development in the company, because Terraform infrastructure code often starts in a small area and then it starts to kind of expand across. And even within one company, there are like different setups. Like this repository is one of the old legacy repos that uses this structure, and then we're moving to like small decentralized repos with modules that's different. So even within a company, we see a mix.
Yeah.
I see a question from Joe. Is it possible to add modifiers to Infracost to take in considering billing concepts such as reservations or savings plans for certain environments, or to remove deleted? Yes, very much so. So in the Infracost usage file, in that YAML file I mentioned, you can say, hey, on these instances, actually assume a 3-year RI. Just like, because by default, we assume the on-demand prices, but you can say, hey, this stuff is using RIs. You can also do things like, hey, these instances don't run for the full month. They only run for like roughly this much hours per month. So anytime you're doing a cost estimate for those, just assume that. And you can also do that at the resource level. So let me just share my screen very quickly to show you. This was another thing we developed with the community, because just the community is awesome. So there's a usage file, and you can say something like, let me just show up. So you can say like my auto-scaling group, all these instances in this auto-scaling group, just assume this RI and assume half a month. Don't assume the full month, right? Because we shut them down after working hours. Now, what happened was we worked with the community, and the community were like, hey, I want to define that at a resource level as well, because if we're doing a lot of like Lambda functions, I don't want everyone to assume that Lambda is free at our company. Give them this baseline. Whenever someone tries to provision a Lambda, just say, hey, it's going to be roughly this much, or you can do t-shirt sizes. So you can have a usage file that says like low, medium, high. So when I run Infracost, I can say, hey, what would a low cost estimate be at my company without me having to define like my specific resource IDs? I could just use your defaults and say, hey, here's low, medium, high. And when you're going, especially through cloud migration projects, when you've got hundreds of apps and you want to kind of move those across, you don't have time to write and profile every application. Instead, you kind of just t-shirt size the applications and say, give me cost estimates for these. So that's like the DIY approach. That's like the usage file approach. The thing we're working on right now with customers on the Infracost Cloud product is to digest the curve and then use blended rates. This is one of those areas, again, that cloud pricing is just too damn complicated. There's different ways you could take those discounts from RIs and savings plans and apply them within AWS accounts or Azure accounts, across teams, and so on. And this is an area that FinOps teams really understand and kind of have deep insights on, But engineering teams don't understand this stuff, right? They're like, hey, what do you mean the instance I provisioned yesterday cost $5 an hour and today it costs $2.50 an hour? Like, what changed? Well, the RI discount changed. That's what changed. Or somebody provisioned the instance before you, they got the discount, you didn't get the discount. So what we see is engineering teams don't understand that stuff, and they don't really need to understand that stuff. So instead of trying to expose all of that complexity to them, instead some companies want us to just show the on-demand prices, because the engineering team's job isn't to worry about RIs and savings plans. That's the FinOps team's job. The engineering team's job is to make sure the system is running efficiently. So just show them the on-demand prices. But some other companies want us to expose the blended rate. So just simplify it down to like, here's the average cost of this instance type. Just use that in the pull request comments. Don't make it complicated. Joe, I guess the answer is yes, and you can configure it. But it's what we see a lot in enterprises. Like if you're working with small startups, it's way easier. But when you're working with large enterprises, people want to be able to configure this stuff so it works for them at their companies. Mm-hmm. And the cloud bill, the larger the company, the bigger pain that is. So that's the area we're focusing on. Where's the biggest pain? And it's the larger companies, not the smaller startups.
Okay. Thank you very much, Ali. Much appreciated. And thank you, everybody, for joining us tonight.
Thanks, everyone. Cheers.